Hello everyone, so in this video let us talk about the second problem from the latest LEETCODE weekly contest 388. The problem name is maximize happiness of selected children. So the problem statement goes like this, that you are given an array happiness of length n and a positive integer k, as you can see here. Now there are n children standing in a queue where the ith children has the happiness value of happiness of I. You want to select k children from the n children in k terms. Okay, so in simple terms, you have some children and you have to select k children among these n children that you are given, and these are the happiness value for each children. Now in each turn, you will select a children. The happiness value of all the children that are not been selected till now decrease by 1. So whenever you select a children, it will be selected, but the other children which are not selected, their happiness value is decreased by 1. Note that the happiness value cannot become negative and can get decremented only if it is positive. Return on maximum sum of the happiness of the selected children you can achieve by selecting k children. So let's say that you are selecting a team. Okay, you are selecting a team of, let's say, k children. Now whenever, let's say, you choose the first person, the other person start feeling that, okay, I will not get selected, so the happiness value keep on decreasing. That's a complete actually logic here, that the every child that you now selected decrease the happiness value by 1, and you just have to keep on setting the maximum sum of the happiness value that you have to select. You have to maximize that. Now it's very, very simple, that it is again a greedy problem. Why? Because you have to first select the very maximum children, and then the next maximum you have to decrease the happiness count by 1, and the next maximum the decrease the happiness count by one more again. So that is how you will keep on selecting the children, and you just have to keep on selecting all the children, so that you have to maximize the sum, which is in the greedy way. You have to just sort it out. The other thing is that if the value that you are decreasing, let's say you are choosing these children, and you have to choose, let's say, k equal to 2. So if you choose the first one, then it will be 3. When you choose the next one, it will be 2. But because 1 second has passed, like we have choose the first one, so the next person 1 has to be decreased from there. Now if you choose the next one, it has to be, let's say, 1, but there has to be decreased by 2. Let's say this value is 3. You have to choose 3 children. Now if you choose the first one, the happiness value is 3. If you choose the second one, which is a value 2, the happiness value is 2 minus 1, that is 1. When you choose the third children, its already happiness value is 1, but it has to decrease by 2, because like let's say 2 seconds has passed, or like 2 children has already been selected. But this value cannot become negative. So this can only become 0 at max. So the total sum will be 3 plus 1 plus 0, which is equal to 4. If you have k equal to 3, similarly. So you just have to use this formula, that you have to just sort out all the children by the happiness value, and then keep on adding the children, and for every next children just decrement the count by 1 more, and just keep on adding until the element that you are adding is greater than or equal to 0. That's it. Nothing much complicated. The code is also very simple, as you can see here, that we have to first sort it out, and then we have to take it everything in long to find out the total, because the constraints are pretty long. The total value is pretty high, and then what we are doing is that we are taking the current happiness of the ith children, because it is int, I convert like type consider to long, and then what we have to check is that if we are taking this happiness, that the ith children, because we are sorted it by the maximum to the smallest, when we are choosing the ith children, what we have to choose is that if we are taking the ith children, if we are taking it, at which iteration I'm taking it, because I have to take the k children. So the first children, nothing is decreased, so I have to decrease it by 0. Then the next children I have to decrease it by 1. The next children I have to decrease it by 2, and so on. So if this value is greater than or equal to 0, then only it is like advisable to add it in the total of the total maximum count of happiness that I want to get. If it is less than 0, then it is already bad. Then it's not like already good to take it, because I cannot take negative values, and the happiness cannot become negative. So if it is greater than 0, that the ith child which I'm choosing, the happiness value minus the time I choose it, at which iteration, if it is greater than 0, then I'll take that and increment it the same value. I can take this as this value only, current h minus I, so that it becomes more sense to you. Then this value has been added to the total, and then just print out the total. So the overall time complexity is O of n log n only. Why? Because we have sorted this out here, which is of O of n log n, and then this is just a for loop, which is O of n. So the overall time complexity is defined by the sorting part, which is O of n log n, and that's a complete logic for this particular problem. and the code part. If you still have any doubts, you can mention in the comment box for this particular video. I will see you in the next one. Till keep coding and bye.